So we're on page 8 of 4.6. This is the special cases of AC method. Lots of times I don't even teach this because you don't really need to know it. You can just use straight on AC method. But sometimes the numbers get large and this is kind of handy. So if you remember it, great. If you don't remember it, that's fine. You already know how to do AC. Factors of 36 that add to 12, blah, blah, blah. But as I was explaining in the last video, if this is a perfect square, which it is, 3x times 3x equals 9x squared, and this is a perfect square, 2 times 2 is 4. So a perfect square means some number times itself will give me that. Like 12 is not a perfect square, but 9 and 4 are. And then we can try a little shortcut method. We always have to check this though, because it's not fail-proof. So you have to check it after you're done, is you take the square root of that, you say what number times itself gives me 9x squared, and that's 3x. What number times itself give me 4? 2. This says the signs will be the same. This says they'll both be positive. So we get 3x plus 2 times 3x plus 2. And we call that a perfect square trinomial when the two factors are the same, because so far we haven't had any where the two factors are the same. So this is just a very tiny little group of problems that this works on. So that's why I said lots of times I don't even teach this, because you can use AC on it and it works fine. But once in a while you'll run into kind of big numbers, like this would be factors of 900 that add to 60. Well, that's kind of big. It might take you a while. So this is a bit faster. But like I said, it doesn't always work, so you have to check it. 9x squared, yes. 6x plus 6x, 12x, yep. 2 times 2, 4, so it works. And then this is how most instructors and textbooks and homework platforms will write it. If your factors are matching, then you just write it as one factor but with a squared, which means this. Do you have to do that? Nope. But that's just one way to write it. Okay, so let's take a look at a couple of these. We're not going to spend a lot of time on it because, like I said, AC method works on every single one of these. So it's not really something you have to learn. So is this a perfect square? Yes. 5x times 5x is 25x squared. Is this a perfect square? Yes. 6 times 6 is 36. So that means I could try the little shortcut where you take the square roots. So square root of 25x squared is 5x. I put it in both of these slots. Square root of 36 is 6. This says the signs will be the same. And this says they'll both be negative. So then I have to check it and see if this works. 25x squared, yep. Negative 30x, negative 30x, yep, that's negative 60x, plus 36, boom, it works. And like I said, you'll have, I don't even think you have a single one on your test that does this, but it's usually like 1 out of 50 or something like that where this will work. So you can always see if it might work, but these both have to be perfect squares for you to even try it. Okay, let's do one more and then you guys can practice one. So I look at 11, I say, is 4x squared a perfect square? That means does something times itself give me 4x squared? Yes, 2x times 2x is 4x squared. Does something times itself give me 1/9? Yes, 1/3 times 1/3. So since they're both perfect squares, that means I can try this. If it doesn't work, then I just go to AC. So square root of the first term is 2x, 2x, all positive signs, so that means plus. Square root of this means what's the square root of 1? What's the square root of 9? So it's 1/3. So 1/3 here, 1/3 here. So we FOIL it to see if it works. 4x squared, yep. 2/3 x plus 2/3 x is 4/3, yep. 1 times 1 is 1, 3 times 3 is 9. It works. So then we write it as a binomial squared, which is common for perfect square trinomials. So all of these are perfect square trinomials because they all have matching factors. Okay, so go ahead and shut off the video and try number 12. So first determine if it's a candidate. Is this a perfect square? Yes. 6x times 6x. Is this a perfect square? Yes. 7 times 7. So once we've determined that, we can try this. But remember, it doesn't work unless we check it. So we have to check it before we can say that it's true. So square root of 36x squared is 6x. 6x. Square root of 49 is 7. 7. This says the signs are the same because the only way to get a positive is a positive times a positive or a negative times a negative. And this says they'll both be the same. So they'll both be negative. So checking it, 36x squared, yep. Negative 42x and negative 42x is negative 84x and positive 49. Boom, it fits the pattern. So then we can write it in its little condensed form if we wish. So that's pretty cool beans, huh? But like I said, rarely see them. Like 1 in 50, 1 in 100. So don't get too excited about that. Most of your trinomials are going to be the nice long AC method, not this short little thing. But at least you've seen it. Okay, the last thing we're going to do in this section is factor by substitution. And yes, this one is on the test. So when we're factoring by substitution, what we notice is it doesn't quite look like what we're used to. We're used to this, 3x squared minus 2x minus 21, right? So what if we could replace those with something and make it look like that? Then we'd know how to factor it. Because right now, I don't know how to factor this. I could FOIL and multiply by 3 and distribute, but that's a lot of work. So let's look at the next page and see what they tell us about this. So you never want to multiply when you're factoring, because factoring means turn it into a multiplication problem. So that's like going backwards. So what we can do, and let's bring that problem, is, oh, it's right here. I was getting ready to write it and go, well, I really don't like that being that quantity. What if I call it u? Every time I see an x minus 1, put in u, and then doesn't it look like a problem we're used to seeing? So that's why we call this u substitution. And you will not believe how many times you're going to see u substitution after this. It's all over the calculus textbooks, college algebra. So anytime you have an equation that doesn't quite look right, see how it has that repeated quantity? You can pull it out and just call it u, and then you get an equation you know how to do. You go, oh, I know how to do that one. That is an AC method problem, just a nice straightforward AC method. So I'm going to take that out, replace it with u. Take that out, replace it with u. So I tell students, when you decide on your U substitution, which it will be the repeated quantity, put it in a box. Why? Because you're going to come back to it in a second. So I didn't put the work for this one out there, so let's go ahead and do it. So there's nothing common, so we're looking for factors of 63. Read the problem backwards, that's subtract to 2. And that would be 7 and 9. Now we have to decide the signs. So this says the signs will be different. And this says the larger number is going to be negative. So 9's a larger, make it negative. The signs are different, so make the 7 positive. So now we're going to stretch it out into 4 terms using that in place of the negative 2u. So we're going to write 3u squared. And remember how I said if you can put your negative first, do that. It makes it so much easier. So minus 9u, less chance for errors too, plus 7u minus 21. So then we group. The minute we see 4 terms, we should jump into grouping mode because that's all we know how to do with 4 terms. So divide each of these by 3u, and we get u minus 3. Bring down the middle sign just like we did on the last 4 problems. And then the GCF here is 7. Put the 7 out in front and you get u minus 3. And then this is when you get excited. Matching. So that tells me I'm on the right track. So I bring that out as a GCF. And then in the second parentheses, 3u plus 7. So that's where this came from. They have it in this one first and this one second, which it doesn't matter. So I just didn't show those steps when I was typing this up. So those are the steps that lead you here. Okay, now this is why we have this box up here to remind us, oh, I can't stop and circle that as an answer because this problem doesn't have u's in it. I can't give an answer with u's. So then I have to go back and take the u's out. So I just put them in to make it look good so I could factor it, but then I do have to replace them. So take the u out, replace it with x minus 1. Take the u out, replace it with x minus 1. Notice I put them in with parentheses because they are binomials. So then I distribute 3x minus 3 plus 7x minus 1 minus 3. I combine like terms. 3x plus 4, combine like terms, x minus 4, and there's my answer. So I did the whole problem by kind of faking it. I took out what looked weird, put another number in, and then plugged it back in at the end. And we call that U substitution. Awesome, right? So let's just barely get started on this next one, and then we'll finish it on the next video. So what's U going to be? What's the repeated quantity in number 13? M plus 2, right? So over here to the side in a box, I say, okay, I'm going to replace M plus 2 with U and make it look like a normal problem like what I've been working in this chapter. So you can always see it repeated, that's your U. So now everywhere I see M plus 2, I'm going to put U. So this turns into 5U squared minus 14U minus 3. Now don't I have a normal problem on my hands? Yes, I do. Usually it's x's, but u's doesn't make a difference. So there's nothing common, so I say factors of 15, reading the problem backwards, that's subtract to 14. And we'll pick up from there on the next video.